ecosystemOS is specifically built for innovation and entrepreneurship ecosystems. It's a digital platform that generates more innovations and growth faster by optimizing entrepreneurship journeys. As you probably know, the success of startup ecosystem development depends on its connectedness and therefore on the free flow of data within organizations across different entrepreneurial communities between information systems from devices to apps, etc. And innovation and entrepreneurship data integration powered by an open interoperability standard that DGOLA is globally leading in the context of innovation and entrepreneurship, enables that flow by ensuring that data is understood the same way from start to finish by individuals, by organizations, systems, and devices. So therefore, ecosystemOS eliminates problems caused by siloed systems. ecosystemOS helps entrepreneurs and startups get timely access to the resources that they need. ecosystemOS makes it possible for every entrepreneur and startup to have a single comprehensive entrepreneurship record that informs and is informed by their entrepreneurship experiences. ecosystemOS also brings generative AI capabilities to startup ecosystems for ecosystem development and more. So therefore, the goal with this solution is higher quality, more personalized and faster support that is simpler for entrepreneurs, support organizations, and everyone who makes entrepreneurship and innovation happen. Ecosystem180 is designed to kickstart the process to optimize entrepreneurship journeys. It is the starter plan of ecosystemOS that provides a suite of 3 powerful applications interconnected through the EOS data repository, setting the foundation for seamless interoperability and efficient ecosystem management. So Ecosystem180 is for innovation and entrepreneurship units with a low level of digital maturity in ecosystem data management, with scarce resources and basic needs to initiate breaking down silos within the ecosystem, increasing ecosystem transparency, and enhancing ecosystem actors' navigation within the local ecosystem. Ecosystem180 basically includes a suite of 3 interoperable applications. So we have Ecosystem Advisor AI that provides 24/7 access to trusted global information covering various knowledge aspects of the ecosystem. We also have a Skyview app, which is a dashboard application offering comprehensive insights into the needs of ecosystem actors. And then we also have Orchestra app, which is designed for mapping, maintaining, and managing information about ecosystem support services, and the Ecosystem Advisor AI knowledge base. Ecosystem180 also includes the EOS data repository for effective data management within the ecosystem. It also allows customization of the name and visual appearance of the interoperable applications to align with your ecosystem's branding and visual style. And basically, this is quite relevant to ensure a seamless and consistent user experience. You also get an allocation within our globally centralized data repository where you can store and manage all your ecosystem data in one place. And with a shared global data repository, all ecosystem actors share the common resource, reducing also the cost and inconsistencies. And last but not least, it also ensures that data is stored in a standardized format, facilitating easy access and sharing across different systems and applications within and between ecosystems. So definitely this open standard approach helps in avoiding vendor locking and promotes innovation through easier integration with other data sources. The applications within Ecosystem 180 are basically interconnected through the EOS data repository, which plays a crucial role in facilitating seamless communication and data exchange among the different applications. This interconnection works like this way. So the EOS data repository initially acts as a centralized data lake. So this centralization means that all applications within the Ecosystem 180 suite access and contribute to a common pool of data. And by having a single source of truth, the repository ensures consistency and reliability of data across different applications. Then when data is entered or updated in one application, it is immediately available and consistent across all other applications. For example, information updated through the Orchestra app about ecosystem support services is immediately accessible in the Ecosystem Advisor AI and Skyview app. So this real-time data sharing eliminates the need for manual data transfer or synchronization, which basically enhance operational efficiency at ecosystem level. Then the interconnected nature of these applications allows for seamless flow of information. For example, insights generated from the Skyview app can be directly used to inform and update the knowledge base managed by the Orchestra app, or to provide contextual information within the Ecosystem Advisor AI. Also, it benefits from a unified experience where the users can switch from between applications without having to deal with disjointed datasets or interfaces. So then this interconnectedness provides a more, I would say, intuitive and efficient user experience. Then when it comes to the collaboration and integrated functionality, the applications are designed to complement each other's functionalities. For example, the comprehensive insights from a Skyview app can inform the AI-driven advice and recommendations in the Ecosystem Advisor AI. And then the use of an open standard data model further facilitates this interconnectivity. It ensures that data formats and structures are consistent across different applications, making integration and data exchange more straightforward. So basically, this interconnected ecosystem of applications center around a robust and unified data repository enables Ecosystem 180 to offer a cohesive and integrated digital transformation experience for innovation and entrepreneurship ecosystems. The EOS data repository is, again, a central component of Ecosystem 180, playing, again, a vital role in managing and coordinating ecosystem data. So the EOS data repository functions as a centralized data lake where all data related to the ecosystem is stored, managed, and accessed. This, again, centralization ensures that data from different sources within the ecosystems is consolidated into a single and unified location. And by serving as the single source of truth for ecosystem data, the EOS data repository ensures this consistency and reliability. So that data entered or updated in one part of the ecosystem is immediately reflected across all connected applications, maintaining that data integrity and reducing the risk of discrepancies. The repository also facilitates seamless interoperability between the different applications within the Ecosystem 180. And basically, it utilizes an open standard data model, which again standardizes the format and the structure of the data store. And this standardization is again quite crucial for ensuring that data is easily accessible and shareable across different systems and applications, both within and between ecosystems. Then, by sharing a global data repository, the costs and complexities associated with maintaining multiple individual data systems are significantly reduced. This shared resource approach also helps in reducing inconsistencies that often arise from managing data in siloed environments. Then it also provides flexibility. So basically, the EOS data repository is built using open source or open source based technologies. This approach provides, besides the flexibility and also customization options to ecosystems, and helps in avoiding vendor lock-in situations. So then ecosystems can extend or modify the data model as per their evolving needs without being restricted to a specific vendor's technology. And last but not least, as part of the ecosystem, as part of EOS data repository, so it also implements robust security protocols to protect sensitive ecosystem data against unauthorized access and threats.
This aspect of security, privacy, and confidentiality has multiple dimensions. It's one of the key aspects of any system. And of course, when we have to first split that into a couple of perspectives. So one is the general software and application level security of information. So relying on the latest security practices and privacy practices for how the software is developed, how systems are created, how those are maintained, which is more from the purely technical aspect of making sure that there's latest softwares and practices in use for application and code level security and reliability. But then the aspect of confidentiality and privacy of information, that is more based on the business logic and business decisions that have been put in place for how systems are operated and managed, and by what type of practices. So here the key aspects are first and foremost the global regulations. That is basically an aggregate of different regulations in different countries. So here we use as a baseline let's say the latest regulations development, specifically regulation like GDPR coming from Europe. That is basically the, let's say, globally leading privacy regulation that also many other countries are adopting. And the basic principles of GDPR is that any data used or entered into the system by user is intended to be used only for that primary function that it is used for or catered for. So in the initial Ecosystem 180 services, one of the basic services is Ecosystem Advisor AI, which basically has knowledge behind it to answer questions that startup ecosystem related questions that different key stakeholders could have. And in that case, the data is processed purely to get a response for the questions addressed by the users. Another aspect is using that information for helping to develop the service quality. So basically the quality of the questions. in that part, the information is processed in such way that they are software-based analysis of the questions asked, and those are grouped and categorized at system level. So not looking at individual questions, but purely looking at the statistical perspective of what type of information is asked for most and what type of quality of answers the system is giving, and then making sure to improve the quality of this information. In addition, users will have opportunity to give their feedback for further input. In that case, the also specific question and answer pair is addressed accordingly. Some of the key aspect is also that the information is not saved. So the interactions, we are not collecting information of who is using the system at 180 level. So it's basically anonymous usage. There is no user login, sign up to collect information about the specific individuals. As such, the data is not considered as personal information at Ecosystem 180 plan. And then finally, as a key piece for confidentiality of information shared, as a basic principle, confidentiality doesn't start from the system receiving the information. The confidentiality starts from those who enter information into systems. And this is usually if confidential information is in use, for example, working on a project that there is a non-disclosure agreement in place, NDA, that agreement defines the rules of how those who have the confidential information should handle that information. That it may include things that information should never be posted anywhere online. So that's the first and foremost applicant to confidential information. So now for the reality, what happens, most of these agreements themselves and related documents flow freely in online systems like email sending to between participants, WhatsApps, uploading to Google Drive and so forth. So in that sense, Ecosystem 180 can be considered a similar type of service, where that information, we don't recommend posting any confidential information into any systems, including Ecosystem 180 plan. And therefore, but if you do, that information is not used for anything. It's not read by humans per se, and it's not stored in the systems anyway. But the first and foremost is to understand the confidentiality agreements that are made between those who handle confidential information in the first place. And then as a final point, I would say that for more sensitive information like identifying individual users with registration or login, and then also catering more specific answers to specific questions actually become available in our next plan, which is Ecosystem 360. So that any more sensitive information actually requires a different plan that is not part of this plan. And ultimately, in starting with Ecosystem 360, also this responsibility of business practices around information submitted with the system is something that is designed by the local ecosystem that is utilizing and putting the system in place from their perspective. So those rules and terms, privacy terms, are custom made per every ecosystem that then adopts 180. That adopts 360 plan. So that's a more broader aspect of security, privacy, and confidentiality.
Yes, there will be a demo next Wednesday as part of the webinar we are hosting. Once we finalize that webinar, because the webinar will be recorded, so then the demo will be also publicly available for everyone. Basically, Ecosystem 180 operates on a subscription basis, priced at 399 euros per month, making it, I would say, an accessible option for ecosystems with limited resources and basic digital transformation needs. Ecosystem 180 is particularly beneficial if you have a low level of digital maturity in ecosystem data management with, again, limited resources and basic needs to initiate breaking down silos, increasing ecosystem transparency and enhancing ecosystem actors navigation within the local ecosystem. The main benefit is that you can initiate this process with a low risk and a very affordable way, moving fully away from the complex, long and expensive procurement processes, and you can have it up and running in a few weeks. Secondly, for the first time, entrepreneurs and startups will have round-the-clock access to trusted global information and various trusted and updated knowledge of the ecosystem in question. And last but not least, without sending any surveys, you will know for the first time what questions entrepreneurs ask the most, providing comprehensive insights and analytics about the ecosystem needs, aiding in strategic planning and understanding the ecosystem's dynamics. The main limitations are that, firstly, Ecosystem 180 does not include custom applications in its basic offering. Custom applications are only possible in a consortium with other ecosystems that share common needs and interests. Secondly, another limiting factor is that Ecosystem 180 does not provide custom APIs or data models unless there is a specific need for them. And therefore, without custom APIs, the ability to integrate Ecosystem 180 with other more advanced systems or applications might be limited, potentially hindering seamless data exchange and workflow integration for users with complex ecosystems. And last but not least, while Ecosystem 180 is being operated by us, by DGOLE, as a software as a service, which reduce complexity and cost, it also means that you have, as an ecosystem operator, less control over the technical infrastructure, and you are dependent on DGOLE for ongoing updates and maintenance. You should upgrade this plan when you need your own dedicated EOS data repository, need to expand the data model from custom data type, or need APIs to integrate with local applications. So basically, we offer setup assistance to help you get started quickly, and technical support is provided through a shared community on Slack where you can connect also with other ecosystems and experts. You will have access to help videos and documentation to assist you in getting up to speed. And custom development of applications and use cases is also available in collaboration with other ecosystems based on common use cases or common needs.
So basically, what we commonly see in the ecosystems adapting. So while there isn't existing, let's say, software as a service type of offering that we have seen by others in the market, that doesn't mean that this let's say the challenge is not maintained or tackled with other approaches. So most commonly seen approaches is custom built ecosystem portal or center of information, which basically is either could be on top of WordPress or something else, or custom built software solutions where everything sits in one big online application with the front end the data and an application as such, oftentimes bearing 100% of the development and maintenance and operation costs by single ecosystem, while at the same time being limited to custom data sets and oftentimes no API interfaces at all, and basically challenges in iterating and developing that software setup forward. Another alternative approach that we see is using some of the globally available platforms that cater similar setups for multiple ecosystems at the same time, where the main limitation comes that the data models are not really known or not able to develop or customize per ecosystem own needs. Also, there is no open standards structures behind those data models often. There is no APIs, or if they are, those are controlled by the system provider without having ability to customize those needs for own ecosystem perspective. Basically catering globally from one provider to multiple ecosystem in a fixed approach. Also, the cost factors can be significant, but most importantly, the access to own data is limited for application interoperability perspective, taking responsibilities of the regulation compliance aspect and other digital developments from the perspective of own ecosystem. And so mainly when looking at in context of ecosystemOS, the key benefits comes from the aspect that you can start with the software as a service type of solution with limited flexibility, and by upgrading you will be able to get more flexibility and customization for your own ecosystem, while still also getting the benefits of collaborative cost sharing amongst other ecosystem using the same system, and also benefits of open standards and interoperability, also sharing data between ecosystems where that makes sense. And finally, also the ability to take full ownership of a full system at the ecosystem ops plan level, meaning that the whole system can be transferred and passed to your own ecosystem ownership and control, with all the benefits of the global connectivity from the interconnection points that you want to make possible, connecting to the global repository that we host in same time. So basically what we have tried to do is optimize the ease of access to get started, and the ability to operate without high costs initially, and be able to upgrade as you need ultimately to have full ownership of the whole system without any kind of vendor locks in between. So really designing a starting point from one starting point, simple and easy starting point, all the way to a bigger system that is still interoperable and based on standards.